All right, and welcome to your screencast of Wednesday, Valentine's Day's homework. It's pages 10 and 11 in your Unit 5 packet, and we're going to be working with solving systems of equation with the method of elimination. Now, the whole thing with elimination is you add two equations together so that one pair of variables cancels out. In order for that to happen, those variables have to have opposite coefficients, the same value but opposite signs. For the examples that we did in class today and that you'll be doing for homework tonight, the equations are not originally set up that way. So you need to look at your variables and look at the coefficients and either multiply one equation by a number or both equations by different numbers in order to get opposite coefficients so that they cancel out. So let's take a look at number 1, and you can see right away x and 4x are not opposites, negative y and 2y are also not opposites. But what I'm going to do is I'm going to work with my y's, and I'm going to multiply both equations, or the first equation, just warming up here a little bit, the first equation by a positive 2. Because if we do that, our y's will have opposite coefficients. So when I do that, I get 2x minus 2y equals 30. Keep your second equation the same because here we have y's with a negative 2 and positive 2 for coefficients. So when we add these two equations together, this will give you 0y, which equals 0, and you get 6x equals 60. Divide by 6 on both sides, we get an x value of 10. Then we want to take that x value and substitute it into one of your equations. I'm going with the first one. 10 minus y equals 15, solve for y. Subtract 10, we get negative y equals 5. Then divide each side by negative 1 to get y equals negative 5. And then you want to make sure you write your answer, your solution, as a coordinate pair, x comma y, 10 comma negative 5. Okay, so for number 2, we've got a 2x and a 5x and a 3y and a 6y. I can make my 3y the opposite of 6y by multiplying by a negative 2. That gives me negative 4x minus 6y equals negative 34. Keep your second equation as it is because our y's have opposite coefficients. When we add our equations together, they will eliminate. We get x equals negative 2, and our equation's already solved for us. So we're going to take that x value and substitute it into one of your equations. I picked the first one this time. So there's your negative 2. 2 times negative 2 plus 3y equals 17. Gives me negative 4 plus 3y equals 17. Add 4 to both sides. 3y equals 21. Divide by 3, and we get y equals 7. So our answer is negative 2, comma 7. Example 3 is getting a little more complicated. I can't multiply just by one number, because we can't multiply 2 by anything to make it the opposite of 5, or vice versa, and we can't multiply 3 by something to make it the opposite of negative 2, or vice versa. So we've got to multiply by two things. We've got to multiply both equations. Since 3y and negative 2y are already opposite signs, I decided to use these variables. And I decided to make our y's have a coefficient of 6 and negative 6. So for my first y to have a coefficient of positive 6, I need to multiply by 2. And for my second equation to have our y value to have a coefficient of negative 6, I multiply by 3. That coefficient of negative 2 is already negative, so I can multiply by just a positive 3. Here we get our two equations. 4x plus 6y equals 32. 15x minus 6y equals 63. Add your equations together, the y's eliminate. We get 19x equals 95. And 95 divided by 19 gives me x equals 5. So we're going to take that x value, substitute it into one of our equations. I went with the first one. 2 times 5 plus 3y equals 16. 10 plus 3y equals 16. Subtract your 10. 3y equals 6. Divide by 3. Y equals 2. Our solution is 5, negative 2. Number 4. 6x minus 7y equals 25. 15x plus 3y equals 42. This one's going to get, going to have some bigger numbers here. You could make a 6 into a 30 and a 15 into a 30, or one positive and one negative. But I again chose to work with my y's because their signs were opposites already. And I decided to make my negative 7y a negative 21 and my positive 3y a positive 21. And I did that by multiplying my top equation by positive 3 and my bottom equation by positive 7. My new equations now are 18x minus 21y equals 75 and 105x plus 21y equals 294. Don't be alarmed when your numbers work out bigger. This is still going to work out nice. Our y's cancel out, so we get 113x equals 369. When we divide 369 by 113, we get the nice answer of x equals 3. Take your 3, substitute it into one of your originals. I used the first one, 6 times 3 minus 7y equals 25. That gives us 18 minus 7y equals 25. Subtract 18 on both sides, so negative 7y equals 7. Divide by negative 7 on both sides, and we get y equals negative 1. Solution, 3, negative 1. All right, let's go to the next page here for number 5. Here is a nice example because I have a 3y and a negative 3y. So all I need to do is multiply my second equation by 3, and my y's will have opposite coefficients. 2x plus 3y equals 12 is the same as the original. And my second equation is now 12x minus 3y equals 30. Add your equations together so your y's cancel. You get 14x equals 42. And divide by 14 to solve for x and get x equals 3. Substitute 3 into one of your originals. I used the first one. 2 times 3 plus 3y equals 12. 6 plus 3y equals 12. Subtract 6. 3y equals 6. Divide by 3. Y equals 2. Final answer, 3, 2. Last system here, we're going to have to multiply both equations by something. You could take your x's and make them negative 20x and positive 20x, or vice versa. Or we could take our y's and make them negative 12y and positive 12y, or vice versa. I decided to work with my y's. And so I multiplied my first equation by negative 4, and that got me my negative 12y. I multiplied my entire second equation by 3, so my y had a positive 12y. And that worked out to give me, when I added these two equations together, negative x equals 7. So we divide by negative 1 and we get x equals positive 7. X equals negative 7. I substituted negative 7 into the second equation here. So I get 5 times negative 7 plus 4y equals 1. That gives me negative 35 plus 4y equals 1. When you add 35 to both sides, we get 4y equals 36, and divide by 4 to get y equals 9. And so our answer is negative 7, 9. One more problem. This is a great review. It says, which function has the greatest range of change over the interval 2 is less than or equal to x is less than or equal to 7. So we need to find the y values when x is 2 and when x is 7. And then we need to find the rate of change by finding the change in y over the change in x, or the change in outputs over the change in inputs. So for my first function, which has an equation, I need to find f of 2. 2 is the input, and I need to find the output for an input of 2. When I substitute 2 in for x, I get 4. So that gives me the point, if you will, 2 comma 4. I do the same thing for 7 when x is 7 and I substitute 7 in for x, I get 44. So that is like having the point 744. Input of 7, output of 44. And rate of change is the change in your outputs, 44 minus 4, over the change in inputs, 7 minus 2. Do your math. Whoops. 44 minus 4 is 40. 7 minus 2 is 5. That gives me a rate of change of 8. Now I want to know who has the biggest rate of change. So now I'm going to look at the table for g of x. And this is a little less work to come up with our outputs. An input... Sorry, I hit pause for a second. An input of 2 here gives us an output of 0, and an input of 7 gives us an output of 45. So rate of change is change in inputs, 45 minus 0, over the change in outputs, which is again, same interval, 7 minus 2. 45 minus 0 is 45, 7 minus 2 is 5, and 45 divided by 5 is 9. So, which interval has, or which function has the greatest rate of change over that interval? The answer here is G. And that's that. Remember, we have a quiz on Friday on all of this stuff.